everyone is familiar with, can you see my screen? Can you hear me? Are you on mute? So this is it. This is our new life. So thank you, Ehsan from Nustian Canada. He and his team coordinated with us to get this going. So we had our first webinar in January, which was smart investing. And today we are focusing on data science. So IBA, again, just sending out a thank you note for reaching out and getting this going. It looks like we have a number of participants interested. So I will not take too much time and just introduce quickly our two speakers. So we have Jawad Ahmed. So he's got 6+ years of artificial intelligence experience, NLP speciality, and I've got these acronyms, guys. And I told you, I am an accountant. So I will read the acronyms as they are. Worked in Dialpad, Talk IQ in the past. He's currently a senior data scientist at Flipp. He's a graduate of NUST from electrical engineering and a master's in computer science from Waterloo. His focus area has been artificial intelligence, machine learning, and data science. Zeeshan, he is our current president of IACC, so IBA Alumni. He is a graduate of IBA, MBA, and BBA. He just finished his data science certification in big data from University of Toronto. He has over 10 years of experience in the banking sector, and he is currently working as an independent consultant for top banks here right now. So I won't take again too much time. Jawad, you have the honors.
Thanks, Mama. I'll wait for Ehsan to share the slides deck, and then I can
share right now. Yes, thank you.
I think we can go to the slideshow mode if possible. Thanks. Thanks everyone for joining in, and thanks Mama for the kind introduction. So I'll just take 15 minutes and cover basic background and overall high level understanding of data science. So next slide. So I'll just give a brief introduction of my past experience. And so I graduated from NUST from SEEK's EE1 program in 2013, and I joined Affinity SatMap in Lahore as an analyst algorithm engineer in the AI team. So that was the time when I got some exposure to data science aspect of things. It was mostly SQL, and the company's business is to intelligently route calls based on personal and behavioral factors in order to optimize the interactions for sales calls or any different kinds of calls. So I worked there for 1.5 years, and that's when I decided to move towards formal education in the domain. And I came to Canada and started program in computer engineering at University of Waterloo, focused on AI, machine learning, more on the computer science aspect of things. Then in 2017, after graduation, I joined a startup as it was out of San Francisco in Kitchener, Waterloo, Talk IQ. They were doing speech recognition and conversational insights. So it was predominantly speech recognition and natural language processing. And then that team was acquired by Dialpad, and then we became Voice AI in Dialpad. So Dialpad now it's similar to Zoom. They do real-time transcription of calls, and then analysis on those calls. So machine learning focused work there as well in NLP. And then recently, last year, I started at Flipp as senior data scientist to give myself more exposure towards the computer vision side of things. But that's just the background I've had in this domain. And next slide, please. So what is data science overall? It's the field of study where we are using scientific approach to get insights from data or to model data in a useful way. Whereas machine learning on the other hand, it refers to a group of techniques which data scientists use to model the data towards a certain task. So these Venn diagrams below give an overall picture of, uh, on the left side, we can see that data science is a very broad subject on its own. Like there are multiple areas of research within data science. It's at the intersection of computer science, math, statistics, business domain knowledge, very important. And artificial intelligence is I would say it's a domain of computer science and has been around from 1960s, 70s. It's just that now that we have computational power that we are fully leveraging the research which was done in the past. So data science overall, I would just say, is a mixture of all that. So artificial intelligence. Uh, it refers to the tasks, computational tasks, which are usually in the realm of human decision making. For example, you can see speech understanding or textual understanding, image recognition. Like these are the tasks which we do, but we do not exactly know what instructions or what's the steps which go into that. I'll touch on that later on, but you can see the different applications. These are normally the tasks which are performed by humans, and how we can automate them or to use AI in there. And that's a high level understanding of AI, and it's being used in all these different domains. Machine learning within AI, it's a subdomain of AI. Like AI has different problems, as in Nash equilibrium is an artificial intelligence problem, or many other problems in finance sector as well would fall there. But machine learning specifically is training certain algorithms on lots of data to allow them to learn certain tasks. So training models using data. Within AI, we have machine learning, and deep learning is a subdomain of machine learning, which refers to neural networks. We hear a lot of words like deep learning. Deep learning is just neural networks, expansion of neural networks to multiple tasks. So that's machine learning, training models using data towards a certain task. So let's consider this simple example. Uh, we have, let's say we have certain features, we call them features or predictors: height, weight, body mass index, and we want to classify the gender. Now you can see all the features are numerical values. We can feed them towards to certain models to predict those tasks. It could be probabilistic modeling or anything, but you can see that the input features are numerical. We move on to the next slide. So within classical machine learning, that's linking to the same problem or the example shown before, these are a bunch of algorithms which have been around for decades. Uh, Linear regression, so they all can work on the data which is represented into numerical values already as features, as we saw in those examples. So we can train these models to draw decision boundaries or to probabilistically modeling the data, so that if a new data point comes in, we can make a prediction that that's a female or male or any problem which we are solving. So classical machine learning refers to mostly statistical models. It is heavily involved statistical modeling, probabilistic modeling, and tree-based approaches. And so that falls into classical machine learning. Move on to the next slide. But let's consider this example now. We have a cat. If we were to write a program to detect an image as a cat or not a cat, how would we would write all, like, if it's just impossible to write image detection algorithm of a cat using code, like with 1,000 lines of code, pixel by pixel. What if we invert the picture? It's still a cat, but that program is invalid now. Uh, Similarly, so all of these pictures are cats, but we cannot write it in an instructional manner because of the problem. So similarly, text classification, we do not have numerical features. We have text and we want to classify sentiment out of it. Just by changing a couple of words, just by adding not to a sentence, it changes the entire semantics of the sentence. So these are the problems where deep learning or machine neural networks come in, and I'll show how. If we so the question to ask is, how do we as humans learn? There are two main methods: instructional and observational. Instructional being do this, 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 follow a recipe. If you do this, 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 you'll have a biryani at the end, let's say. Or and second is observational. Observational, and that's how mostly we learn as humans. Like, how does a kid learn that that's an orange, that's an apple? By having those things, or observing those things over and over and over again. So this is how our cognition develops, that we understand how. But if we ask ourselves even now that why do we think an orange is an orange, we have an input, we have an output. Like, the input is orange, we know it's an orange, but we do not know what instructions go in our mind to detect to that point. And that's where machine learning comes in, or deep learning, where we have input variables and output, but we do not know what exactly goes in there. And we want machine learning to learn that recipe of. So the philosophy of neural networks is basically based on how humans perceive information, how our cognition works. So the idea is, can we develop such algorithms which can learn different algorithms? And I covered that point. So Andrew Ng is a famous person in neural deep learning, machine learning domain. So he has a saying: any decision which a human brain can make in less than a second can be potentially automated. Some of those decisions are image recognition. We see things, we know what it is. Speech recognition, we hear something, we know what it is. So these are the decisions which we do not know how they happen in our brain, but we know the outcome, but we do not know what exactly instructions are involved in that task. So that's where it comes in. So major deep learning would be divided into multiple tasks, but there's sequential modeling where the sequence of input is important. Like stock prediction, you cannot predict a price of a stock tomorrow if but just by taking today's. So you take a series of data points to predict this. So the sequential uh, did the information is hidden in the sequence. Similarly, text, it's all sequential. And speech recognition, natural language processing, other tasks where there's information in the sequence of the data. Non-sequential data modeling is where we consume some information in one go. Image, we just look at it and we consume, like, it's not a sequential operation. Character recognition or other visual tasks as well. So it's mainly divided into computer vision, natural language processing, which in fact is sequential versus non-sequential. uh, so these are main, yeah. And a typical life cycle of a data science project, or I think Zeeshan would talk more in detail on that, but it's having a business understanding, data acquisition, but data acquisition from the lens of machine learning model, as if like, what kind of data can we use, or how do we do engineering, feature engineering or processing on that, which can leverage, so that we can leverage the machine learning model at its best. Like, it's not just big data and holy water of machine learning would work. Uh, there's most of the effort goes in cleaning the data, and 80% of the time data scientists spend, I think that's on curating the data. And it's not on the training the models. That's the easier part, in my opinion. I think the effort goes in ensuring that what we are feeding into the model actually makes sense. Uh, yes, so some applications in these days, like I'm covering more on neural network side, because so you would see it's being used in like just by using our computers. Like Google has this Google Meet recently has this feature of blurring the background, so you can change the background. So it's computer vision task. They're detecting image segmentation, uh, image classification. Cars have those speed detection, like the speed sign comes in and it shows you on the dashboard. So these are all computer vision tasks. Speech recognition is a whole area of research in its own, different accents. They break down to the very simple unit of speech, which is phoneme, even smaller than an alphabet, image captioning, subtitling, like there's numerous applications, and each area in itself is a active area of research on its own. So that's why I'm saying data science is a very broad term to capture it all in one talk. But I'm trying to give a high level coverage of what different topics are involved within data science. There is analytics part of data science, which is more on deriving insights from the data. And then there's a whole another part of data modeling, which ties closely with machine learning. Uh, so that's all I have, and I'm on time. So that's great. All right, thanks, guys.
Perfect. Thank you, Jawad. And I think we're going to keep questions for the end, Ehsan.
Yes, questions will be
Okay,
at
perfect. So Zeeshan, over to you.
Assalamu alaikum. Thank you, Mama. Let me share my screen first. Hello, everyone, and Assalamu alaikum. I would be giving a walkthrough of a data science project, which was my capstone project at Brain Station, where I did my recent graduation as a data scientist, a certification, 3 months, day in, day out, 8 to 10 hours every day. So I try to build a prediction model for used car vehicles. And for that, I took this data set from Kaggle, and this data set has been scraped from Craigslist. That's a US-based used car selling platform. The scraping has been done every quarter, and I've got around the file is 1.3 GB containing 450,000 observations. That's the rows, and there were 26 dimensions. So a holistic review of what the data would be, and then what I did was I imported for if you're doing if you're working on Python, you have to import different modules and different libraries to use them afterwards. So that's what I did initially, and then imported my data. While doing that's the first thing you do is you do exploratory data analysis, that EDA, and data cleaning. And as Jawad rightly said, 80% of the time is involved in data cleaning. And he was correct, because that's where you have to code to clean it, sanitize it, and bring it to a level where you can do modeling on it. So this was the structure of my data. And for doing data modeling, you have to get everything in. Everything has to be numerical. So check this out. I have ID column, URLs, region. So these are my 26 columns. The numerical columns were literally 1, 2, 3, 4, 5, 6. And in these 6 columns, I would be using price, year, and odometer when I would be doing my modeling. And I would be converting all of my other non-numeric columns to numerics afterwards. So the object columns are all non-numeric. So what I did was I dropped columns which are not being utilized, which would not be utilized at the end, like ID, URL, region URL. When is literally an ID, and image URL. And this is my first visualization, where you see the Ford is the highest selling vehicle, used selling vehicle. That gives you an idea that it must be the highest selling vehicle, because Ford has multiple models too. So, but Ford, Chevrolet, and Toyota, and Honda, and Nissan. Moving on, what I tried to do was I tried to find out which were the best selling models. And check this out. Ford, the manufacturer, and then the models are F-150. That's a truck manufactured by Ford, and Silverado. But this was, I haven't done any cleaning yet. After cleaning my data, that's what I did. I cleaned it, removed unnecessary characters, and also deleted like instances, so that I don't, because initially I had checked this out, 3,657 models. I cleaned them, brought them to 293, because 3,657 would be too much, and they were all non-numeric values. to bring them to numeric, you have to it, it would be a cumbersome process, and that would not give me a good model. So I decreased 91% of the number of vehicle models, but the total data set was decreased by 13%, as those are not really important to my model building. And moving on, so I then, after cleaning it, isolating my data, cleaning it, and then committing it to my original data set. And now the visualization were changed. This was to give you an idea how important cleaning our data is. And check this out: the manufacturers were the same, but at the same time, models changed. And Silverado by Chevrolet was the highest selling truck, and then Ford F-150, followed by Ram 1500 and Jeep. So it gives you an idea that trucks and Jeeps are more in demand rather than sedans. And in sedan category, I would be doing deeper visualizations to give you an idea that Japanese are the highest selling sedans. So I isolated my data sets for different manufacturers to visualize them afterwards, and there you go. So the American models, the best-selling models like Ford car models, Chevrolet, Jeep car, and Ram car. These are some of the visualization for American manufacturers, and then these are for Japanese manufacturers like Toyota. Toyota Camry is the highest selling, and Honda is Honda Accord, and followed by Tacoma, Honda Civic, and that's Nissan. I'll just move forward because it's too long and I won't be able to complete everything on time. So, and this is really interesting. So my data, you can always plot your everything through my latitude and longitudes. I plotted using Folium, and this is an interactive graph. Check this out. You can find out. So these are where the advertisements were posted from, and majorly there was the used cars were sold within the eastern region. That's New York and Philadelphia. So this I tried to visualize through different types of models, but this was too much data. So it gives you an idea that east side is more cars are sold on the east side. But and so now I wanted to reduce my clean my model on by the year of the cars, my vehicles. And check this out. So we had model years since 1980, visualizations from 1980 to 2020, and I had to make a hard decision. And then 2000 was the year I started. 2000 to 2020. 2021 wasn't included because there were no used cars sold in the same year. These are some color visualizations as good, excellent, like new, fair, new, salvage, and the white. So check just to get an idea of my. I'll just skip a couple of my visualizations and move forward. So what I did, then I moved. What I have to find out is the NaN values, and they have to be taken care of. As you can see, condition had 41% NaNs. This is the first, and NaN values are literally there's nothing there. We have to either fill them up or remove those columns. And those decisions have to be made. So what I did was I removed everything below 5%. That's title status, transmission description, latitude and longitudes, because they were not to be replaced by me, and also fuel. And I filled everything, the remaining paint colors, as unknown, because I had to find paint colors like 28%, and I couldn't remove. I couldn't just reduce my data set by 28%, and cylinders and conditions too. But cylinders, what I did was I imputed cylinders from the same category as, for example, you know that all Honda Civics would be 4 cylinders. So that's what I did, and this is the code through which I found. There you go, and odometer too. So what I did with odometer was I averaged with different conditions as excellent and good and fair and like new, and then filled the NaN values with their averages. The only thing left was drive and so now check them out. The car models and manufacturers, they were unique. These many car manufacturers, and now my challenge was to impute them to numeric values. And for that, what I did, and also the states. So there were 51 states, and if you have in data science, if you transfer your data to, there's a curve which is said to be high dimensionality. So if I would use everything, my data would expand and the columns would increase to thousands and probably more than thousands, and it would be really difficult for a model to predict. So I have to make some. What I did was I distributed all my states into 4. That's Northwest, Midwest, South, and Western states, and then assigned them numbers, and that's how I imputed my numerical values. And the price column, which was my predicted column, was skewed on the right side. That's because there were low price vehicles more, and it was skewed distribution. Had to be turned to normal distribution to get better results. That's where I used log 1p to get my normal distributions done. Finding some correlation between my data to check for, as Jawad said earlier, 80% of the time is where if you do cleaning, and that's, you can see, I started at 2020. It's like I've utilized more than 80% of my time explaining how cleaning is done, and still it isn't complete. So after completing it, also assigning dummy variables is where you assign numbers to your non-numerical columns and converting them to number columns. So for example, in fuel there were 5 categories. Every category would be given a number, and that would be weighted, and it would expand the expand the column. For example, like car model, Volkswagen Passat, every other row would be 0, and where there's Passat listed, it would be 1. That's how you so the columns would increase in numbers. That's why I said in curves of dimensionality. Then I had, interestingly, a column named as description, where what I did was I did natural language processing on my description column to assign numeric numbers to my data, and get so for that I used TF IDF, and I imported Stropford's Wernet's Punkit, and that's how I limitize my data before passing it through the TF IDF logarithm to find my to assign tokens, numeric tokens, and get it into numeric. And check this out. So every word in my description column is given a number, and it increased that's how I did my natural language processing on the data. Next, I'll be moving, and I have only a minute, but I'll take a few more. I'll be moving to my tree models, and I'll skip neural networks at this time because it would be over time. If that's okay with, sorry, I'll check the chat. Yeah, chat. So again, here what I did was I exported everything to my disk because this file was my vehicle processing, and so my trained NLP, XText NLP, and validation. I distributed my my data into train, test, and validation sets, so that I would train my model on my train set, test validator number validation, and test set would be used when I find my best parameters for one of the models after doing grid search. I'll explain you what grid search is. The first model I tried was decision trees, and decision trees is where different decision tree is a model where although it's prone to overfitting, and you can find out that the train set my R square, which is the accuracy, which is where you find how successful your model was 100%. That's one. That's perfect. But my R2, because my model was that did overfitting, and the result came out to be 0.88. That's really bad for my model because it would not do well on training or validation or testing sets. And my mean absolute error rate was 185. Those are my scoring matrices. So what I did was I tried to reduce the overfitting by building by the scoring method, and check this out. So my this is my validation and this is my train. So validation sets, the scores are always below 90, and 18 would be the max depth. Max depth. You can control overfitting by max depth, and that's where I controlled by having 17 as a number, 17 as the max depth, magic number. And check this out, my train the scorings declined. And then if for hyperparameter tuning, because there are certain number of hyperparameters which you can tune to find the best optimal results. My mean absolute score was 24. Oh, sorry. Mean absolute score was 2422, and it's on validation, and 8.877. 0.877. Check this out. No, there's something wrong here. And 2440 and 0.88. It increased from 0.77 to 0.88. But then there's a random forest, which is an ensemble algorithm. It combines all the decision tree models together and provides us with an average and gives us more accurate results. And that's what it did for my model building too. And you can check this out. The R2 score, that's the R square score on training and validation sets increased tremendously from the R2 score for my decision tree was 0.88, remember, and now it's 0.94. And at the same time, mean absolute error score was 1865. Now it's 1465. But random forest regressor takes some more time. It takes around it took me around like 564 minutes. And while I was training my decision tree model, it took me around 15-20 minutes. So you can imagine how long it takes and how deep it goes. Although I could have increased it, but that's one of, and these are the prediction visualization of the prediction. The straighter the line, the more of 45 degrees it is, the better. But these are all the outliers, and so this is a table you can find out the R2 squares, mean absolute error scores, and run times. Now moving on, that's the crux of any model building. That's grid search with KFolds cross validation. If you're not doing it, you will not optimize your parameters, and you will not get the best results from the model you have built. And what it does is it folds your data into 5 folds, 1, 2, 3, 4, 5, and then 5 inside each fold too. So it does validation and train on the other 4 parts, and then on the second part it does training, and it is an iterative process. The formula for doing the KFold is here right now on the right hand side. And I built the pipeline to pass my model parameters and estimators and model random state 1, and Bingo, they got the validation is 0.94 and my mean absolute error is 1453. 1453 means if I would be predicting, for example, if I predict 1450, if I predicted a price on a Honda Civic, which is $10,000, so you can say plus minus 1450. So there's a low limit and there's an upper limit. I think I've taken a lot of time, and if you have any questions, you can reach out to me through my LinkedIn, or you can check this code out on my GitHub profile. I'll share my GitHub profile. Thank you. Sorry, organizers, I took 5 more extra minutes.
Not a problem. Thank you so much for the amazing talk, Zeeshan. I'm receiving feedback that they're pretty much blown away with what you're showing. And thank you, Jawad, as well. Amazing talk to give us an overview of what data science as a field is. We've got some questions. So without further ado, let me just, oh, there we go. I've got some questions here. So I guess if we can get started with the first question, I think it's directed at you, Jawad. It's probably, were you at Waterloo on a scholarship? I don't know, like if it has anything to do, but like if you want to talk about your program, maybe like at your University of Waterloo a bit.
Sure. So I had a background in electrical engineering. So jumping right into computer science is difficult. So I started in computer engineering, not on scholarship, but 3 months into that program, I got funded into research. So it worked out in that way, but I did not come to Canada thinking that I have the scholarship, but I got it later on. Does that answer the question?
Yeah, absolutely. So we've got another question by Seth. In the older days, captioning was done manually. So now AI generates captions. I guess probably Jawad would be a better person to answer this as well. Like how captioning is done, like how subtitling or captioning is done.
Yeah.
So we just wanted to get some context there, I think, Seth here.
So that's deep learning. Is image captioning. Like Facebook came out with the feature of face detection like years ago. That was first, and then image captioning. Now on YouTube, you listen to songs and they have the subtitles and they're auto generated. So it's all using deep learning, which is, I would say, very advanced form of machine learning at that point to do image captioning.
Perfect. Yeah. So we have lots of questions coming in, but this is like one question that at least I had in my, not in my mind, but like I get asked these questions all the time. So I know, Zeeshan, you have a certification from University of Toronto as well, a certification that I've been eyeing for a few years, I should say. But yeah, so like this one question I would like you to answer really is, how can I, like, if I do not have a coding background, how can I enter? And I know you have a business background and you came into the data science field. How was your experience? What would you recommend someone who is from a non-programming background? How can he pursue or enter this field?
You can start off by online learning too. There are a couple of courses in Udemy, and although Python is one of the top-notch industry practices at this point in time, and everybody thinks that Python is the only thing. If you learn Python, you will be the guru and a data scientist, but that's not the case. Python controls majority, but at the same time, you have to you have to know the concepts in SQL and how the data is retrieved. What are the different concepts? How the data is structured? What's structured, unstructured, and stuff about data. And at the same time, then you need Git, you need to be aware of how Git bash is used, how to use command line and uploading your projects and other stuff, and also R. So the question was regarding how someone comes in. You can start by different certifications. My UFT certification was really amazing, but at the same time, the BrainStation certification gave me a lot of in-depth practice and execution and training at the same time. So we had classes every day, and they provided you with all the tools and technologies to be used by a data science or data science expert while on the job. So everybody was job ready. and that's a boot camp. Boot camps is a new thing because certifications used to attend a class every week. In a boot camp, you are working, studying, learning, and also applying your concepts on a daily basis, and those are inculcated in your blood to get you trained in. So I would recommend boot camps if you want to switch your fields.
Perfect. Yeah, I appreciate it. And Jawad, I know you already have an electrical engineering background. I don't know if you want to build on top of that, like how someone in a different technical field can actually, draw parallels in this field. And is there like a bit of a learning curve for a technical person too, or how would you advise the journey for that person?
So I would say people coming from engineering background, it's compare or mathematical background. I think people coming from maths background are very strongly suited to data science, and electrical engineering inherently is 80% maths. So it puts us in that position naturally to pick those things easily. So I can say that when I started program at Jawad, I had never used Python before. So I see language is just a tool. If you can do C and you would have done it in engineering, it's very easy to pick up Python. The I think the crux lies in, as Rishan said, in understanding the problem and making decisions along the way, and that comes with having an understanding of mathematical aspect of things. Uh, so, I mean, neural networks is all linear algebra. Linear algebra is the course which I hated at NUST, and then came to realize that's the core foundation of neural networks: linear algebra, matrix factorization. Um, yeah, so maths background is highly preferred. Like it can be difficult if you do not have mathematical background to jump right in. Yeah.
Perfect. Absolutely. Thank you so much for answering that so comprehensively. We have another question for Fakir here. Can you, and I think this is directed at Zeeshan, it says, can you please repeat that how the price is converted to a normal distribution? And then second part is, it is necessary that the output variable should be normally distributed.
Yes, that. Can I share my screen again? So,
Absolutely, yeah.
yep. So while I was doing pre-processing, and so data, your dependent variables has to be found out if it's normally distributed or not your independent variables, because independent variables would, sorry. So dependent variable is what you're trying to predict. And then for that, I found out through this normal distribution plot, and it was rightly skewed. So I use an NP log of 1p to find out to have my data as normally skewed. That's a stats function, logs. That's 1p of the log, or you can use simple log2 to have it normally to convert your data as to towards the normal distribution plot. It's simple. What you have done, what you have to do is assign df, the column name equals to np. That's np is a short form of numpy. That's where I imported. So numpy log of then df, and then the price. That's the column I wanted to convert. Did I answer your question correctly, or is there anything else?
Yeah, let us know, Fakir, if that answers your question, but feel free to, if you have any other questions on that. Thank you, Zishan, for that. Let me go to the next one. Saf is asking, can speakers share some basic resources, training courses from, YouTube, Coursera, Udemy, if you wish to start a journey? I think you answered some of it. And what are some certification, easy, basic to advanced, difficult for data science that we can do, which are recognized by the industry? So yeah, I guess I could put this question in front of you guys. Like, do you think there is like a specific course, or there's like a brand name that is recognized in the industry if you're going and doing those kinds of certifications? Those courses are on your resume? Does it create like an impact that would be greater than any other course out there in the market? Like, I think I'll start with Jawad maybe.
I think Zeeshan can answer that better, but I, I think generally Coursera has certifications. They do not hurt. Like if you take but at the same time, if you're saying like, is that a guarantee to industry? Uh, I'm not sure about that, but it definitely doesn't hurt to have those. Boot camp, as Jean said, is a good idea to get started. But even with all these, as a fresh graduate coming out, even if you do certifications, 10 courses, 15 courses, it can put you towards a data analyst role leading to data scientist. But uh, it has become more competitive. Like it's not the case how it was maybe 3-4 years ago that certifications could directly lead to. That's just blunt opinion, but Zeeshan can have more.
Yeah, Zeeshan, over to you.
Thank you, Jawad. You were absolutely right. Certifications won't guarantee you, and MBA degrees or any degrees won't guarantee you any positions. As you must know, you're an electrical engineer, and I was an MBA, and I was an MBA in finance, starting my marketing job as my first job, and then moving towards banking. Certifications do provide you with a door, but it has to be opened by you, and there's a very long process to get jobs in data science. There are tools. These are only tools and ways to get in, like certifications, boot camps, and degrees. But at the same time, how to showcase your talent, and for that you have to upload whatever you're doing on GitHub, and or that's a place where everybody wants to see, or any interviewer or your recruiter wants to see your coding skills first before hiring you. Also, at the same time, you need a lot of networking to get to know people, so that they know your skills, and they would be able to recommend you. And doing courses and staying on top of everything, that's what is required.
Absolutely. Yeah, very rightly said. I think networking plays a huge role in any industry or in any career for sure. I know I used to attend like some events prior to joining this industry and obviously before COVID. There's this app called meetup.com, or this website as well, right? So they used to do like a lot of data science events. They probably still do. But they were like amazing. We would have a data scientist from IBM, from TELUS, from Bell, from everywhere else, and they would just do these sessions so they can give an overview, and they would hire people based on that participation of folks, right? So it just demonstrates your interest. I'll quickly go on to the next one. I know there are tons of questions coming, and we only have 8 minutes to go, and really appreciate you guys both answering those questions in a very comprehensive way. Next question is Farhan is asking, how should a high schooler prepare to go into this data science field? And I think the second question by Sayed is also somewhat related, just like, are there any data science summer related jobs for undergrads? So I don't know who wants to take a stab at it, Jawad or Zeeshan.
For an undergrad, I think that's great if you're at that point and thinking about it. So focus on maths, like maths. You can do a bachelor's in pure maths and you can be a great data. So you can do a bachelor's in physics and be a great data. Most of the best data scientists I've seen are PhD in physics, astrophysics. So it's maths I would highly put value on. What was the second question? Sorry.
Like, are there any summer jobs for undergrad?
So I think at this point in time for undergrad, if you are really interested, there is so much resources. Kaggle is a great starting point. You can start competing in projects, and whatever you do there is building up your resume and building up your profile. So when you graduate, you'll be way ahead of the other candidates who have not done. So I think there's lots of resources. If the drive is there, you can and yeah.
Perfect. No, I think I'll go to the next question because I think Jawad answered that, and Zeeshan, I probably have another question for you anyways. Saf is asking, are there any career counselors available we can talk to for this field?
I can take a stab on it. Yeah, career counselors, there are, I don't know about your background, but if you've done any, for example, I would give my example. I completed my boot camp from BrainStation, and now I have a year's career counseling with the BrainStation career staff, career accelerator staff, and they provide me with all the tips and tools and also different aspects of how to approach things. And at the same time, networking and networking. So that's an important thing. You can and LinkedIn is a very important platform where what you can do is you can connect with people, and don't just send them random requests of connecting with them. Send them a message and just interact with them. Ask them questions which are related to data science. Not just pose them a question as please give me a job, because nobody is there with a basket of jobs in their hands. Just connect with them, ask them relevant questions, and build your relationship. And that's how you build connections. And that's a barrier. That's a very excellent career counselors available in the market on LinkedIn.
Absolutely. Yeah, very rightly said. Just for housekeeping purposes, I know that we're getting a lot of questions and we might not have time to actually get them all answered over here, but you already have our email addresses. You can go on to nustian.ca website or IBA Canada Alumni.ca website, and feel free to contact us and get us send us your questions, and we'll be sure to connect you with the speaker here. This session, by the way, is being recorded, and the recording will be available on YouTube and other mediums, and we will make sure that the link is given to all the participants here. I'll quickly jump on to the next question here. Fakir is asking, in traditional software engineering, when a client reports a bug, we fix it, we find the error and fix it. But like in ML, let's say if there's a prediction that goes wrong or like an image prediction, how can we debug such production ML system? So I think maybe Jawad, if you want to answer that one.
So the first thing, ML only comes in when the expectation is that it's not going to be 100% correct. If we could solve something 100%, we would not need machine. So there's always this metric of accuracy associated with the model. And we do not, in software engineering, if there's a bug, we know where it is. In machine learning, we train generalized models. So it's really difficult to make change as in, oh, this image was predicted wrong, fix it. We cannot unless we retrain the model. And that involves certain thinking. So, so the way it's done in production systems is that there's a monitoring feedback loop for model which is running. It's making predictions, and then it's being monitored that how it's performing. And if you have above 90% accuracy, you're doing a great job. So, yeah, the expectation is not there for it to be accurate. And that's why if we are using machine learning for drug discovery, for testing a person if he has cancer or not, per se, there's a high cost in predicting those things wrong. So the business problem gets taken into account. What's more important here, precision or recall? Is it okay to make a false prediction, or is it okay not to make a prediction at all? So there's always this expectation of error. Yeah.
Perfect. Thank you so much. So I know we're timing out. I'll probably have one last question for Zeeshan here. And it's an interesting one, especially surrounding the COVID world that we are in. It's talking about how can AI ML predict stock market prices in case an unexpected event like COVID happens. So he's giving an example like how, there were some algorithms that were predicting $60 for a stock price for Air Canada, but it dropped to $12. So it is okay to say that, failed algorithms can cast doubt over their ML AI in future.
It's a very difficult one because you can't predict COVID. Otherwise, the world would not be in the state. And but at the same time, there are stock models which can predict stock prices. And Jawad rightly said, nothing can be predicted to cent. There are some deviations and some errors, and those have to be taken into consideration. But there is a model for predicting stock prices, that's ARIMA, ARIMA, and also you can predict stock prices trends through Facebook Profit, FP Profit. Those are the two models which I recently also used them. If Jawad, you allow me, I can. Oh, sorry, Ahsan, you allow me, I can show them like a short?
Absolutely. Yeah.
Yep.
Yeah.
So this is FB Profit. I try to do Nasdaq, and so I imported Nasdaq prices from 1970, and this is how the price, the closing price index is. So distributed training and red is test. I'm moving it really fast. I'm not showing anything. So this is a crunch of it. So check this out. The lowest. That's how the Nasdaq performed over the years in on a monthly basis. So these are trend analysis, and that's the most important thing. Other than that, there are different time. As Sarimax, I don't have that at this point in time. Probably I have it here. Sorry, folks. Yeah, ARIMA model is there. So the SPY closing price, and so this is how we decompose the observed values, and the tested and then the predicted one. So they you can have the predicted is the blue one, and although it doesn't predict the outliers, but it it can look at the joint dots. So it's somewhat it can predict.
Thank you, Zeeshan. Asad here, I asked that question. So just because the time is short, so I just jumped in. So that means your ARIMA model for NASDAQ is showing that it will remain in the mean line. Like it would be in the mean, like in an average position, it would progress an average without any correction expected. Is that the conclusion of the model that you just shown? Just asking.
Facebook Profit decomposes your trends, and those trends. So what it does is it gives you an average of every day for like 1st of January from 1970 to 1st of January 2020. It would give you an average, and those points are plotted along the line for the whole year, 1 year.
Thank you.
I'd just add to this point.
Yeah.
There was many questions on stock price. Uh, so ARIMA is time series modeling, any time series modeling. Stock exchange is something which fits in that problem space. But I would be very wary of any stock prediction models. There's just so many variables which are not accounted in, like, and people from IBA would have better knowledge on these. There's so much so yeah, I don't think someone has really nailed down that problem of stock prediction even now. It's just market difficult to predict.
Perfect. Thank you so much. So looks like we will have to wrap it up, guys. Thank you so much for an amazing talk. There are certain questions that we couldn't get to. I'm sorry. Like I know Hasnan, you had a question, and I know Maria, you had a question. But we'll make sure to send them to our speakers here and somehow get the answers back to you. Feel free to reach them out on their LinkedIn profiles as well. I was thoroughly excited before this event as well, and I'm still thrilled. There are just so many things to learn. And I think Asad also brought up very, very interesting questions about like how, like ML and AI algorithms are failing. How can we say they will do in future? I know Nate Silver also talked about it when, all the elections polls were saying that Trump will lose in, like two elections before, but they failed miserably. So it's not to say that the algorithms are failing. There are certain underlying assumptions that are there, and that needs to be refined in every round, in every epoch that we say, right? So all of these things matter. But like I said, thank you so much for everyone joining us today. The recording, like I said, will be available. We will send out a feedback form. Please feel free to tell us what went wrong or what was good about this webinar. And with that, I hope you have a wonderful weekend. Thank you so much, Jawad, Zeeshan, and everyone on the line. Take care, guys. Bye.